Hello, class. This is going to be the AP Physics 1 lecture for today. So looks like we have 2 viewers right now, 4 viewers, that's good. So in AP Physics 1 we have just finished waves, and so now it's time to move on to the last topic before the AP test, which is basically electricity. And so today what I'm going to talk about is a couple of things. The first thing I'm going to talk about is something called electric charge. Electric charge is denoted by Q, and it's basically a measure of how strongly something interacts electrically. So it's a property of matter, just like mass is a property of matter. So everything has an electric charge. So the units of electric charge are called coulombs, which is denoted by C. And so if something had 1 coulomb of charge, that would be a huge amount of charge. Oh, Bugger is trembling here, so let me pick him up. Let me see if I can do a lesson with Bugger. So 1 coulomb of charge is a huge amount of charge. Okay, most things have a lot less than 1 coulomb of charge. So there are really 3 charges that you should know about. The first charge is the charge of a proton. So proton is one of the 2 things that's inside a nucleus of an atom. And a proton has a charge of plus 1.6 times 10 to the minus 19 coulombs. Okay? So 10 to the minus 19, so a very small amount of charge. Then there is, oh, and by the way, that is sometimes abbreviated. The charge of a proton is abbreviated as E. Bug, what's wrong? He's just trembling. Can I get a num-num? Thank you. Good boy. The charge of a neutron is 0 coulombs. That's why it's called a neutron. It's neutral. Well, let me check the questions. Oh, okay. Sebastian has a question. How do we submit our answers for daily items? You don't submit your answers for the daily items. All you do is you submit how many of the daily items you tried on Friday. Okay? So, and then next we have the charge of an electron, which is minus 1.6 times 10 to the minus 19 coulombs. So it's opposite the charge of a proton. So electric charge, it can be positive, it can be negative, it can be 0. Okay? If you want to know what is the net charge of something, that's just equal to the sum of all the individual charges that are in the thing. So however many charges there are. If you have for example, an atom, atoms have a net charge of 0 because they have an equal number of protons as they do electrons. Okay, so now that we know what electric charge is, let me check the questions again. What is an example of something that has 1 coulomb of charge? Nothing that I know of. If something have 1 coulomb of charge, then that's a question from Ray. I don't know anything that has 1 coulomb of charge. Mostly it's going to be a very small amount of charge. Okay, so let's see. So now what I want to tell you about is something called Coulombs Law. Okay, and this is the law for the electrical force. Okay. He's just asleep. And so what the situation we want to imagine is we want to imagine 2 charges, Q1 over here and Q2 over here, and they are separated by some distance which we'll call R. And so there's going to be a force between them. So the first thing you need to know about is the direction of the force. And basically you need to know that opposite charges attract and likes repel. Okay? So if you have a, let me move this here. If you have a plus next to a plus, those are like charges, so they would repel each other. If you have a negative next to a negative, those are like charges, so they repel each other. If you have a plus next to a minus, they will attract because those are opposites. If you have a positive next to a neutron, If you have a positive next to a neutron, then there's going to be no force because the neutron has no charge, so it's not positive or negative. Okay, I'm going to pause to check the questions. What are coulombs based on? Good question. So, and that's a question that I'm not going to answer because I don't know the answer to that question. I don't know what coulombs are based on. Okay, so now I'm going to give you the actual equation for Coulomb's law. So that tells you the direction of the force. Okay. Now what I'm going to show you is the equation for the force. So the equation for the size of the electrical force is K times the absolute value of Q1 times Q2 over R squared. Okay? And so, Q1 times Q2, that's just the product of the two charges. 1 over R squared, that's the distance between them. K is called the Coulomb constant. And its value is 9 times 10 to the 9th Newton meters squared per Coulomb squared. Okay, so we can use this equation. So let's just do a little example just to see how this equation works. So let's suppose we had 2 electrons. Okay, so if these are two electrons, then Q1 is going to be minus E. Recall that E is the charge of a proton. And then Q2 is going to be minus E as well. And let's suppose that they're separated by a very small distance. Let's suppose that they're separated by 2.3 times 10 to the minus 9 meters. Okay, so let's calculate the force between these two electrons. So we have K, which is 9 times 10 to the 9th, times Q1, which is minus 1.6 times 10 to the minus 19. Can you guys hear bugs snoring? Times Q2, which is also minus 1.6 times 10 to the minus 19. And I'm doing the absolute value of those. Keep in mind, this is going to give you 1.6 times 10 to the minus 19 squared. Not 2 times 1.6 times 10 to the minus 19, but squared. And then we divide that by the distance between them. 2.3 times 10 to the minus 9, that squared. And we get a force. Let me grab my calculator here. Can you see Hazel on the couch? Where's my calculator? Okay, class, I don't know where I put my calculator, so I can't find the numerical answer to this, so I'm just going to say that it's who knows how many newtons. And then as far as the direction of the force, it would be repulsive. Because an electron and an electron are like charges. Okay? I am going to flip the page over and just talk just really briefly. I'm almost done. I just wanted to talk about similarity to the gravitational force. So you might remember that the gravitational force is G m1 m2 over r squared. And if you compare that with the electrical force, which is K Q1 Q2 over r squared, you can see that they both depend on distance in the same way. So see how they're both 1 over r squared and 1 over r squared. Okay? G, the universal gravitation constant, which controls the strength of gravity throughout the universe, is analogous to K, the Coulomb constant, that controls the strength of the electrical force throughout the universe. And then you can see that mass determines the size of the gravitational interaction. Charge determines the size of the electrical interaction. So these are very similar forces. Okay, so I hope that you were able to learn at least a little bit from that. And let me check the questions before I sign off. The unit for electrical force is the same as the units for any other forces. So that's a question.